Hi everyone, and welcome back to Maths and Physics with Mr. Simons, where we simplify maths and physics and we get you exam ready. Today's lesson is still Euclidean geometry, and we're solving Theorem 1 problems, but this time also proving congruency, right? So as a previous video, I did Theorem 1 with Theorem of Pythagoras, now Theorem 1 and congruency. Right, so prove that triangle ADB is congruent. Three lines there means congruent to triangle CDB. So if we look there, we want ADB, which is that triangle there, congruent to triangle CDB. Right, now they say given that D is the midpoint of AC, so what do I mean with that? If D is the midpoint, then AD must be the same length as DC. O is the center of the circle, so if O is the center of the circle, then OA is a radius, and OC is a radius. Alright, so let's see if we can do congruency. So D is midpoint of AC, and O is the center, so I can say in triangle ADB, so ADB and triangle CDB. Right? Can say that AD equal DC because D is the midpoint of AC. So AD is the same length as DC. Then now you see I'm going to say ADB and CDB are equal to 90 degrees. And the reason being the line from center, right, meets up with the chord and divides that chord into two equal halves. So if that's the case, then it must subtend a 90-degree angle there where they meet. Right, so midpoint chord states then that if this is 90, that must be 90 because this is 90 and that is 90. Right, and the four around there, all four would then be 90 degrees. So ADB equals CDB equal 90 degrees, midpoint chord. So that is where Theorem 1 comes in. And you see this line TB belongs to this triangle, and it belongs to that triangle. So DB is then referred to as a common side. So I have a side, I have an angle, and I have another side, right? And that is one of the reasons why two triangles would be congruent. So I can say triangle ADB is congruent to triangle CDB. My reason side, angle, side. Right? So I hope you follow. Right, let's go to the next problem. Prove the triangle OAB. So from OAB, that whole big triangle there, is congruent to OCB. So OCB. So in triangle AOB and OCB, AO and OC are both radii. So therefore they are equal. That line OB belongs to this triangle. My apologies, and it belongs to the second triangle there. Therefore, it is a common side. So we say OB equal OB, common side, or you can write OB is common. Right? And then, from what we've proven in the previous problem, problem 1, AB equal BC, reason being, this triangle was congruent to that triangle. So AB equal BC, because they are congruent triangles. Therefore, triangle AOB is congruent to triangle OCB, and there we have side, side, side. So side, side, side. So hope you follow. I hope it makes sense. So I'm just showing you I can pop in Theorem 1 into a congruent problem. You forget about Theorem 1 and how it works, and you don't see, you can't finish the congruent problem. Right? Continue practicing. As I said, God will reward your hard work. Right? You have to put in the effort and become the greatest version of yourself. Right? I'm proud of the fact that you are still watching my videos and you are prepared to work and practice. And I promise you, the more you continue and the more you tell me what you need, the more I'll be able to help you. I've been doing this for over 20 years. God bless. Bye.